Even today, I'm amazed by the way threads of history intertwine in unexpected ways, leading seemingly disparate ideas to converge at a single point. To me, the story of the Logo programming language and its connection to artificial intelligence is one of those fascinating coincidences. I remember the early days, when the idea of a computer that thinks was little more than science fiction to most people, a concept relegated to the halls of the most prestigious universities and the minds of a few visionaries. And in the midst of that ferment, the idea of a virtual turtle, an icon of simplicity, emerged. Unbeknownst to many, it shared a direct lineage with the boldest ideas of artificial intelligence. If I had to point to a starting point, I would have to talk about LISP. For those unfamiliar with it, LISP was the language of the artificial intelligence pioneers. It wasn't a language like the ones we know today, with rigid syntax and predefined structures. It was a language that breathed flexibility, designed to handle lists and process symbols, not just numbers. This ability to manipulate information so fluidly made it perfect for early artificial intelligence experiments, which sought to simulate human reasoning, logic, and language. I myself saw how LISP became the de facto language for the most ambitious projects, from the first automatic reasoning systems to natural language processing programs. And this is where Logo comes in. For many, Logo was the language of the turtle, the first introduction to programming for generations of school-aged children. But at its core, Logo wasn't a completely new invention. It was, in essence, a simplified dialect of LISP. Seymour Papert, the genius behind Logo, wasn't just an educator. He was an artificial intelligence pioneer, a colleague of Marvin Minsky, and was immersed in the culture of LISP. The decision to base Logo on LISP wasn't an accident. It was a conscious choice, a way to bring the underlying ideas of artificial intelligence, symbolic thinking, and data manipulation into an accessible and playful environment. By programming the turtle to draw a shape, the child was, without knowing it, practicing the same principles of problem decomposition and procedural reasoning that an artificial intelligence programmer would use for a much more complex project. I remember my conversations with Papert. He wasn't just interested in teaching programming, his vision was much deeper. He believed in the power of programming to shape the mind, to cultivate what he called computational thinking. According to his philosophy, programming wasn't just about giving instructions to a machine. It was a way of thinking about how to solve problems, of breaking down a large goal into small, logical steps. For him, the Logo turtle was more than a toy. It was a tool for children to become epistemologists, to learn about learning itself. And this idea, this belief in the importance of breaking down problems into manageable parts, is the backbone of artificial intelligence. Every machine learning algorithm, every neural network, is fundamentally a manifestation of this idea, a way of breaking down a complex task into a set of simple operations that a machine can execute. Furthermore, Papert's concept of microworlds was, in my opinion, a precursor to training environments for artificial intelligence. The Logo turtle lived in its own microworld, a space where the rules were clear and predictable. In this environment, children could experiment, make mistakes, and learn to correct them. This is exactly what we do with artificial intelligence models today. We give them a simulated environment, a digital microworld, and allow them to learn through experience and error correction. The turtle's microworld, with its geometry and simple logic, was a simplified version of a laboratory for intelligence. If I think about it, Logo's legacy in artificial intelligence isn't a legacy of code, but of ideas. It wasn't that Logo was used to create world-conquering artificial intelligence programs, but that the ideas that drove it were the same ones that drove artificial intelligence. The Logo turtle was a physical manifestation, a tangible symbol of the abstraction of computational thinking. It was a bridge between the world's most advanced ideas in computing and a child's mind. And to me, that is the most powerful and lasting connection. Today, when I see the advances in artificial intelligence, in systems that learn from experience, in algorithms that break down complex problems into manageable steps, I can't help but see the shadow of the Logo turtle in some corner. It is proof that the most powerful ideas can emerge in the most unexpected places and have an impact far beyond their original purpose. In that sense, Logo not only taught children to program, but it also sowed the seeds of thought that, decades later, would blossom in the field of artificial intelligence. And that, to me, is a story worth telling.